Yes, good morning. Today we're going to talk about section 5.6, factoring trinomials. As you can see, we're spending a lot of time on factoring in this chapter, and we're going to cover yet one more type of factoring trinomials. Now let me review with you what is the meaning of the word or the verb to factor, or the act of factoring. Remember, factoring is the process of rewriting, or to rewrite, of course, equivalently, equivalently, a sum as a product of factors. Right? So a term is an element of a sum. A factor is an element of a product, hence the word factoring, or the verb to factor. All right, in this section, we're going to talk about factoring trinomials. Let's jump right in. If I ask us to factor something like this, this is a trinomial. And anytime I see a trinomial I want to factor, it makes me think I can unfoil it, really, and write it as a product of two binomials, right? I think we can all see I can rewrite this sum as the product of x plus 10 times x plus 10. You can always check your answer. Remember, factoring is the reverse, or some say the inverse of multiplying. If I go left to right here, I'm factoring. If I go right to left here, I'm multiplying. Let's check it out. X times x is x squared. That checks out. The outer product is 10x. The inner product is 10x, and that adds up to 20x. And of course, the last product is positive 100, so that checks out too. So in the end, factoring trinomials, basically it's a trial and error process that enables us to, I call it, unfoil a trinomial sum. Let's try another one here. Factor, scroll up, x squared plus 10x plus 24. Alright, if I have a little experience with this, well, I can learn to see some shortcuts here. Notice, if this last term is positive, that means these signs must be the same, the signs in between on both the binomials. And if this sign is also positive, that means these signs both must be positive. Okay, so that's a little shortcut. Let's see, the first terms, well, x squared, the only way to break down x squared is x times x. So now I've really got to concern myself with last terms here that multiply to 24 and that add up to 10. Right? Well, I think I see it. 6 and 4 do it, right? X plus 6 times x plus 4. And if I multiply this out, of course, I'll get x squared plus 4x plus 6x is indeed 10x plus 24 is the last product. Okay? I think you'll agree a lot of the battle here is to get the inner and outer products to add up to this degree 1 or middle term in my trinomial. Let's try another one. Factor x squared minus 16x plus 55. Well, in the first two examples, both signs, or all three signs of the trinomial, were positive. Here, the middle one is negative. Well, let's see. If this last, again, my goal here is to write this as a product of two binomials, right? If this last term is positive, that means the signs here must be the same, either plus plus or minus minus. And if this second sign is negative, well, that means they both must be negative, since that negative sign on that middle term must come from somewhere. Alright, I know the first terms in those binomials have to be x and x. There's only one way to break down x squared. And now I'll need factors of 55. Well, I think I see it. 11 and 5. Yeah, that'll do it. And if I want to check, x squared is the first product, minus 5x minus 11x indeed adds up to a minus 16x, and of course plus 55 is the last product. So my final answer if I'm asked to factor this trinomial, is going to be the binomial product x minus 11 times x minus 5. Notice, multiplication is commutative, so I could have written this answer. I could have reordered those two binomial factors, and that equivalent answer, of course, would have been fine also. Alright, factor y squared minus 17y plus 72. Alright, here, this one, somewhat similar to the one above. I'm going to try to break it down into a product of binomials, and again, it's basically a trial and error process. The first terms in the binomials have to be y and y. This sign is positive, means the sign in between, the signs in between are the same. This sign is negative, that means they both must be negative. Alright, so I'm going to have y minus something times y minus something. What do I get here? 9 and 8? I think 9 and 8 will do it. And we could check it. Y squared minus 8y minus 9y is indeed minus 17y. And minus 9 times minus 8 is positive 72. So, final answer, y minus 9 times y minus 8, and on to the next example. Factor x squared plus 4x minus 21. Well, here the last term is negative. That means if I try to unfoil this as a product of two binomials, well, these last signs are going to be the same. Because the positive, the only way it is negative is to get a positive times a negative, right? So I know my answer is going to look like this. I've got to play around with some factors of 21 here. I think 7 and 3 will do. Let's check it. Again, the big battle here is really to get the inner and outer product to add up to this middle degree term here. It's easy to check the first product in your head. It's easy to check the last product in your head. Let's see if I get the inner and outer products right. The outer product is minus 3x. The inner product is plus 7x, and indeed that adds up to 4x. So my final answer, x plus 7 times x minus 3, or of course x minus 3 times x plus 7. Okay. Multiplication is commutative, and on we go to the next one. More factoring trinomials. That's what it's all about today, factoring trinomials. So factor the following expression. How about x squared plus 2x minus 24. Again, this last term is negative. That means one of these binomials is going to be x plus something. One of them is going to be x minus something. I'll need an inner and outer product of 2x. Let me think for a minute here. Factors of 24. I get a little nervous when I see 24 there. 24 has got a lot of possibilities. 24 and 1, 12 and 2, 6 and 4, 8 and 3, and let me see. I think I see it. 6 and 4 will do it. Yes, it will do it. The outer product is minus 4x. The inner product is positive 6x. That indeed adds up to a 2x. And of course, the first product is x squared, and the last product is negative 24. So final answer, x plus 6 times x minus 4. Okay? Alright, all the examples we've talked about so far, I've had a lead coefficient of 1. Well, what about when the lead coefficient is not 1? Well, it gets a little more complicated. If I'm going to break this down as a product of two binomials, well, the previous rule that we talked about holds. If this sign is positive, the last sign is positive, these middle signs must be the same. either plus plus or minus minus. If this sign is also positive, they both must be the same positive. So right away I know my answer is going to be formatted like so. 2x squared, well 2 is a prime number. There's only one way to break down a 2x squared. That's 2x times x. So things are going to be a little more complicated here because our first terms are not the same. Alright, factors of 6. Well, I've got several options, 6 and 1, 3 and 2, and because these first terms are now different, I would probably also have to consider 2 and 3 and 1 and 6. Only one of these layouts is going to work, and I think I see which one. It's going to be 2x plus 3 times x plus 2. Let me check it. 2x squared, fine. Outer product, 4x. Inner product, 3x, and those do indeed add out to a 7x, and 3 times 2 is 6, the last product. So I get 2x plus 3 times x plus 2. Right? And once you find a layout that works, it is unique, at least with regard to reordering the factors. I could write my answer like this, but it's equivalent. It's the same binomial product. Right? Once you find a layout that works, the answers to these factoring problems are unique, at least up to reordering of the factors, right? By commutativity of multiplication. Let's try another one. Factor 3x squared plus 13x minus 10. Well, again, that lead coefficient is not 1. That's going to make things a little harder. This last term is negative. That means one sign is going to be positive, one's going to be negative. Before I deal with the signs, let me break down the first product. 3x squared can only be broken down as 3x times x because 3 is prime. Now let me think. What I'm going to suggest here, factors of minus 10, I need factors of minus 10 such that the inner and outer product are 13x, positive 13x. Let me think. Well, there's 10 and 1. There's possibilities, 1 and 10, 5 and 2, and 2 and 5. And again, I've got to consider the reorderings because these first terms are different. Alright, let me consider these sets of possible last terms one by one. If I have a 10 and 1, my outer product is going to be a 3x and a 10x. Well, 3x and 10x, one of these is going to be positive, one is going to be negative, so that's not going to work. How about 10x? Let's see, 30x and 1x, too big. That's not going to work. How about 6x and 5x? That's not going to work either. I think we've only got one more chance. Let's see. The inner product here will be 2x. The outer product here will be 15x. And yes, I can play around with the signs there to get 15x and 2x to add up to a 13x. Let's see. 3x and x in the first slots, 5 and 2 in the last slots. I'll need a plus 15x and a minus 2x for my inner and outer product to add up to a 13x. So I think I've got it. 3x minus 2 times x plus 5 will be my final answer. And again, you can reorder those factors if you like. Alright, it's a little harder when that lead coefficient gets big. Let me give you another example here. X squared minus 26x minus 15. Alright, things get a little nastier when the lead coefficient gets big here. Well, 8x squared, I can consider 8x and x in the first slots, or I could consider 4x and 2x in the first slots. Now 15's got a lot of options. I can say 15 and 1, or 1 and 15. I could have 5 and 3, or 3 and 5. And again, I can have the same options in the last slots with that different arrangement in the first slots. Alright, so really I have 8 possibilities, and the idea here is with practice you could eliminate some extraneous possibilities. I think I see something happening here. I'm going to try the 4x and 2x option in the first slots. Let's see, if I have a 5 and a 3, let me check out. 5 times 4x is 20x. 3 times 2x is 6x. And yeah, I can play around with the signs to get 20x and 6x to add up to a negative 26x. So I think I've got it here. I'll have 4x and 2x in the first slots. I'll have 3 and 5 in the last slots in that order. And let's see, I'll need a minus 20x and a minus 6x to add up to a minus 26x. Notice, if this sign is negative and this sign is negative, well, then through a trial and error process, we do have the correct answer here. Let me check it out. 8x squared minus 20x minus 6x plus 15. Oh, hang on a minute. Made a mistake here. Let me get a fresh screen. Let's see, I think there's a copy error on the problem. Let me recopy this problem. Factor 8x squared minus 26x plus 15. I had written a minus 15. Alright, if this sign is positive, well, again, that means the signs in between must be the same, either minus, minus, or plus, plus. If this sign is negative, that means they both must be the same negative, right? Alright, so that helps us out. 8x squared. I'm going to try 4x and 2x again, because I think we can find, well, factors of 15. You could have 15 and 1, 1 or 15, 5 or 3, or 3 or 5. I think I see it here. Again, 20x, negative 20x, minus 6x is minus 26x. Yeah, so that works out. Let's check it again. 4x minus 3 times 2x minus 5. All right, I'll get 8x squared, if I check it, minus 20x, minus 6x, plus 15. All right, so again, correcting that copy error, I do get the product I need. Okay, so here's my final answer. 4x minus 3 times 2x minus 5. Okay, final answer. Final, completely factored answer. These get a little nasty sometimes. Let's see if we can do better on this one. Factor 15x squared plus 45x plus 30. Alright, now what I'm going to do here is notice all these terms, all these 3 monomials have a GCF of 15. So I'll always look for a GCF first, really in any factoring problem. That's going to make our life easier here. I can factor out a GCF of 15, and I think you'll agree it's much easier to factor at this point. So factor means to factor completely. Yes, I can factor out a GCF, but I think I can factor this further, factor again is a trinomial. Factoring and I think x plus 1 times x plus 2 will do it just fine. I could check it. X squared plus 2x plus 1x is 3x plus 2 is the last product. So final answer 15 times x plus 1 times x plus 2. Very nice. Alright, this one I grabbed out of your homework list. It's a little nastier. Factor completely Alright, again, look for a GCF first. Always look to factor out a GCF first. And I think I can spot a greatest common factor in all three of those monomial terms. Clearly I've got a factor of 2 embedded in each, and I've got one factor of y embedded in each. So I can factor out a 2y working my distributive law in reverse. I'll get x squared minus 6x, right, minus, see if I factor out a 2, I'll get 7y squared, right? Alright, now let's think for a minute. Take out, let me check that. 2x squared y minus 12xy squared minus 14y cubed. Yes. I believe I can factor this again. Right. Now my last term is not a constant, it's a multiple of y squared. Well, I think I can rig it like this. If my first terms are x's, and my last terms are going to be multiples of y, I can try a 7y and y, then my inner and outer product will be multiples of xy. Or I made a little bit of a copy error here. That should be a minus 6xy there. Did you catch that? Minus 6xy as that middle term, right? Alright, let's see if we can play with our signs now to get the right inner and outer sum. X times x is x squared, checks, plus 7xy. Well, and minus xy, no, that's not going to work. I'll need a minus 7xy for my outer product, plus 1xy for my inner product, and that does add up to a minus 6xy. And the last product, of course, is minus 7y squared. So completely factored, I'll have 2y times x plus y times x minus 7y. Alright, let's look at some others, more exotic ones. Factor this trinomial. Remember, in this section it's all about factoring trinomials. Alright, well, first thing you want to do is get it in standard form. Arrange your terms in decreasing degree. Alright, and I can do that as long as I tag that negative sign along with the a squared. I can say this is equivalent to minus a squared plus 4a plus 32. Alright, now it's always easier to factor when you've got a positive lead coefficient. So what I'm going to do here is factor out a negative 1. You can always factor out a negative 1 by changing the signs of all the terms left inside. And once I factor out a minus 1, don't forget to include the minus 1 in your final answer here. I think this trinomial here will factor again. I'll get A's in the first slots. And let's see, 8 and 4. 8 times 4 is 32. And I think I can play with the signs such that I get an inner and outer product adding up to a negative 4a. The outer product here is 4a, the inner product here is 8a, and if I put a negative sign on that 8 and a positive sign on that 4, I think I get the correct factorization. Let's check it. First product, a squared. Inner and outer product we already checked is minus 4a, and the last product here is minus 32. So I'll get minus 1 times a minus 8 times a plus 4 as a completely factored final answer. Factor. This one's maybe easier than you might think. 5x squared plus 4x plus 1. Well, let me think for a minute. 5 is prime. That means those first terms must be 5x and x. The last term here is 1. Well, there's only one way to break down 1, and that's 1 and 1. And there's going to be no way to get 5x and 1x to add up to a 4x here because all signs are going to be positive here. Alright, so this is my only option, and it doesn't work. The inner and outer product there is 6x, not 4x. In this case, I call this a prime polynomial. It cannot factor, or I would just say the answer is prime. I think our author would call this polynomial prime. Cannot be factored as a product of two binomials. And some polynomials are prime, just like some numbers are prime. Let's factor minus 2x squared plus 3xy plus 5y squared. Well, again, I'm going to factor out a negative 1 first. Just to give me a positive lead coefficient. Well, you've got to change the sign of all the remaining terms. Let's look at 2x squared minus 3xy minus 5y squared, of course, times negative 1. And I believe this trinomial, this remaining trinomial, does break down. Again, 2x squared breaks down as 2x and x. 5y, well, let's see. 5y squared. I'm going to try 5y and y in the last slots as shown, because then I'll see the outer product will be 2xy, the inner product will be 5yx or 5xy, and if I play with the signs I can get the outer and inner product to add up to a minus 3xy. Alright, what do I need to do? I think the minus 5y has to be negative, or the 5y has to be negative, and the y value here has to be positive. Check it out. I get 2xy positive minus 5xy does add up to a minus 3xy, and notice the last product will be a minus 5y squared, just what we need. So final answer, let me rewrite it. Minus 1 times 2x minus 5y times x plus y. Alright. Factor. 56 a squared plus 42a minus 70. Alright, when the numbers get bigger, the factoring problems get a little harder. And if I stare at this long enough, I think I can see a GCF here. Again, always look for GCF first before you do anything else. And I think all of these numbers are multiples of 14, are they not? 14 times 4 is 56. 14 times 3 is 42, and 14 times 5, 5 times 50, yes, 14 times 5 is 70. Alright, I can factor out a GCF of 14. Alright. And I believe this remaining trinomial is prime. And if that's true, though, then this is my final answer. All I can do is factor out a 14 here and call it a day, at least for this problem. 14 times 4a squared plus 3a minus 5. Factor. Last one today. Minus 3a squared x squared. This is from your homework list. Plus 15a squared x minus 18a squared. Again, look for GCF first. I think I see a GCF of, let's see, 3 and at least 1 power, 2 powers of a are common. I'm going to factor out a 3a squared, but I'm going to do even better than that. I'm going to factor out a minus 3a squared, and again, the reason I do that is so my lead coefficient in the trinomial that's left is going to be positive. Makes it easier to factor. Alright, so I'll get an x squared in the first slot here. Of course, I'll need minus 5x and plus 6. Right? X squared minus 5x plus 6. Looks good. Let me erase that parentheses kind of far out. Alright, and again, I think I can factor this trinomial. I think I see it. X and x. Again, if this sign is positive, these signs must be the same. If this sign is negative, they both must be the same negative. So I'll get x minus something times x minus something. And I think we can all see it now. It's going to be x minus 3 times x minus 2. Let's check it. X squared is the first product. Minus 2x minus 3x is minus 5x. That's the middle product. And plus 6 is the last product. So minus 3a squared times x minus 3 times x minus 2. Okay. Final completely factored answer. Alright, so I'll call it a day for section 5.6, Factoring Trinomials.